Hello, ladies and gentlemen, and welcome back. Welcome back. Root Beer here, looking at question number 5 on our 2010 Euclid paper. So we've got two parts here, light bulb, then written, same as usual. And what have we got for A? If f of x is 2x plus 1, and g of f of x, that is g with f plugged in where all the x's would normally be, is equal to 4x squared plus 1, determine an expression for gx. Okay, so we want a nice little, I guess, polynomial for g. Okay. So, one thing to think about is, well, what could g possibly be? What could we have for g? And if we've got 4x squared for our composition, well, think about if g had any x cubes, then we'd have g of f of x would have f of x cubed, and that would be 2x plus 1 cubed. Now, we don't really need the full thing, but the fact is there's an x here, and there will be an x cubed in the rest of the expression, but we know g of f of x is just 4x squared, so g can't have cubes or fourth powers or anything like that. G's got to just be sort of a plain ordinary quadratic. Okay, so it's something x squared plus something x plus c. That's what g looks like. So we could start the question off, or sorry, not start off, because we've already started, but we can continue on with the question and try and figure out, well, what are these values? What makes g what it is? Because we know that g of f of x, so one way to write it would be a f of x squared plus b f of x plus c. But we also know that would be 4x squared, I think it was plus 1. Yeah, 4x squared plus 1. Okay. So, but we know what f of x is. It is 2x plus 1, right? Just before I continue on and finish out the calculation, got to make sure. Okay. So that would be a 2x plus 1 squared plus b 2x plus 1 plus c. And we expand this out, a 4x squared plus 4x plus 1 plus b 2x plus 1 plus c. So we have 4ax squared. We're going to group like terms together, so 4a plus 2bx, and then a, b, c, or a plus b plus c gives us our constant term. And we know that's got to match up with 4x squared plus 1. Now, polynomials are only equal if their coefficients are equal. So we get a nice system of equations. So 4a in front of x squared has to be equal to 4. The 4a plus 2b has to equal to 0 because there's no x terms. And the a plus b plus c has to equal 1. Well, pretty quickly we get a is 1. And from there, we get 4 plus 2b is 0, so b is negative 2. And then we get 1 plus negative 2 plus c is equal to 1. C's got to be equal to 2. So g of x should be x squared minus 2x plus 2. And that's the expression we're looking for. Okay? So, that's not the only way to do the question. You could probably try and what I guess I would do, since we know what the composition here is, and since f is a linear term, this is a unique thing we can exploit because it's linear. It wouldn't necessarily work if it's a quadratic, but you can have an inverse for f, so there's a way to do another composition and cancel f back out. I think that might be a little bit messier, but it's certainly another way that you could approach the question. Okay, so now we're on to, 5b. A geometric sequence has 20 terms. The sum of its first 2 terms is 40, the sum of its first 3 terms is 76, the sum of its first 4 terms 130, determining how many terms in the sequence are integers. Okay, well, I can figure out the first few terms now. Okay, and since I know it's geometric, I know what the sequence looks like. All geometric sequences look like the first term. To get from the first term to the next term, you multiply by the same number as you do to multiply and get from the second term to the third term. So you start with the first term, and then you just keep using what is called the common ratio r, and you just keep multiplying it on and on and on. So we know a plus ar is 40. We know a plus ar squared is 76. Immediately those two together tell me that ar squared has to be 36. First four terms is 130. So that one and the second equation together can let me solve for ar cubed. It's going to be the difference in those. So 4 to get up to 80, and then a 5, so 54. And this is enough to figure out r. So r is just the division of those two. And how do we get from there to there? So divide by 2 to get 18, multiply by 3, that gives you 54. So my common ratio is 3/2. Okay. And I'm showing my work. I'm not just saying, well, r is 3/2, and I've shown it. I've got my equations. You would line them up better, I suspect, and actually show your calculation, but it's all there. So we can work out a. So we know 36, and we know 54. Divide by r. So that is to say multiply by 2 and divide by 3. So divide 36 by 3 is 12. Multiply by 2 is 24. Same thing again, divide by 3, multiply by 2, and you get the first term, which is going to be 16. Okay, and we can keep going. In fact, it's 20 terms. We could write all 20 terms out, but I suspect we're going to lose it in just a bit. So 54, now I'm going to figure out the next term. So divide by 2 is 27, multiply by 3 is 81, and then the next one's going to be 243, multiply by 3, and then divide by 2, and suddenly we start to not have integers, and they want to know how many terms are integers. So these 5 are integers, and then we get a fraction, and the next one will be another fraction, 729 over 4, and it's just going to keep going. Now, it's a written question, so how do we argue this? Okay, because I think there's just these first 5 that are integers, So notice we start with a equals 16, and that's 2 to the 4. Now I'm focusing on powers of 2 because each time we multiply by r, we lose a power of 2 and we gain a power of 3. And eventually, when we hit 81, we just have powers of 3, no more powers of 2 anymore. The common ratio r is 3/2. So we see the nth term is 16 r to the n minus 1. But let's write that as 2 to the 4, 3 to the n minus 1 over 2 to the n minus 1. Better written as 3 to the n minus 1. And now, dividing those powers of 2, we can simplify. It's going to be 4 minus n plus 1. So it's going to be 5 minus n. So this will be a fraction for any n greater than 5. Okay, so beyond the 5th term, so we might say, so only first 5 terms are integers. And that's all we wanted, was just to determine how many terms. We didn't have to sum them up or anything. All right, so that finishes off question number 5 quite nicely. Up next, of course, question number 6.